There was a time when the oceans turned into a war zone of monsters. 5 million years ago, at the edge of the Miocene and Pliocene epochs, Earth was ruled from below by predators so massive they reshaped the food chain itself. Megalodon crushed whales with bone-splitting force, while leviathan cetaceans hunted each other with teeth the size of your hand. Survival belonged only to those evolved for sheer size. But in the midst of that hierarchy of strength alone, a different kind of predator emerged. Orcinus citoniensis didn't look like a threat. It was smaller than the monsters around it, lacking the crushing jaws or titanic bulk of its rivals. But what it lacked in size, it made up for in something far more dangerous: coordination, awareness, and strategy. This early ancestor of the modern killer whale didn't chase power through force. It earned it through precision, hunting in packs, reading its environment, and executing ambushes with near military efficiency. It defied every expectation of what ruled the sea. Long before orcas claimed the title of apex predator, citoniensis had already set the blueprint, not for domination by strength, but for supremacy through intelligence. Roughly 5 million years ago, near the boundary of the Miocene and Pliocene epochs, Earth's oceans reached their peak in both biodiversity and brutality. Global sea levels were higher than today, with temperatures elevated by 2 to 4 degrees Celsius across much of the planet. Warm currents surged through newly opened seaways, like the Central American Seaway and the Indonesian throughflow, creating nutrient-rich upwellings that supported explosive growth in marine life. But with abundance came competition, and the rise of some of the most terrifying predators the oceans have ever seen. This was the reign of Otodus megalodon, a super predator estimated to reach lengths of 15 to 20 meters. With serrated teeth over 18 centimeters long and bite forces exceeding 180,000 newtons, it could bisect a whale in a single strike. Fossilized whale vertebrae with megalodon bite marks have been recovered from sites across Peru, South Carolina, and Japan. Grim reminders of a creature that turned the oceans into its personal hunting grounds. But megalodon was only one of many threats. Toothed whales like Leviathan melvillae, discovered in the Pisco Formation of southern Peru, rivaled megalodon in size and weaponry. With a skull over 3 meters long and tusk-like teeth in both jaws, Leviathan likely hunted large baleen whales, attacking them with bone-breaking precision. Elsewhere, macroraptorial sperm whales such as Acrophyseter and Zygophyseter patrolled coastal waters with sonar-guided aggression. Even smaller marine mammals weren't safe. Prehistoric delphinids like Hemicinus and Australodelphus used speed and agility to compete for fish and squid in increasingly crowded ecological niches. Pinnipeds like Allodesmus and Analearctos, early relatives of modern seals and sea lions, moved inland or into more isolated habitats as larger predators pushed them out of open water. Giant seabirds, such as Pelagornis sandersi, with wingspans up to 7 meters, scoured the ocean surface for carrion and prey, occasionally diving after young or weakened marine animals. No depth, no current, no coastline was safe. The fossil record paints a grim picture of these waters. Bone beds from the Yorktown Formation in North Carolina, dating to roughly 4.5 million years ago, show overlapping remains of whales, sharks, and marine birds, suggesting mass predation events or sudden die-offs likely linked to environmental volatility. In the Mediterranean basin, the fossilized remains of juvenile whales, dolphin skulls, and shark teeth have been uncovered together in late Pliocene strata, indicating multi-predator feeding zones and possibly coordinated hunting behavior. And yet, into this violent, overpopulated, and highly specialized marine ecosystem came Orcinus citoniensis, a cetacean unlike any other of its time. First described in 1883 by Giovanni Capellini from fossils found near Volterra, Italy, O. citoniensis measured only 3.5 to 5 meters in length, barely a quarter the size of the apex predators it shared the sea with. Its remains, later recovered from Pliocene marine deposits in Tuscany and the Piacenzian strata of the Mediterranean, include partial skulls, jaws, and vertebrae. What stood out wasn't size or weaponry, but structure. Its cranial features suggest refined echolocation and a larger-than-expected brain-to-body ratio. The maxilla and premaxilla show muscle attachment points ideal for rapid jaw movement and fine motor control. Unlike Megalodon or Livyatan, which relied on brute trauma, citoniensis likely tracked prey through acoustic cues and attacked with coordination rather than chaos. Paleontologists now believe that citoniensis may have been one of the earliest cetaceans to employ pack hunting, not unlike modern orcas. In this model, smaller whales work together to corral prey, isolate weak targets, and strike with organized precision. In the densely competitive world of the late Miocene and early Pliocene, this would have been a radical departure from the solo ambush tactics that defined apex predation. It was not the fastest, not the strongest, not the largest, but somehow it was thriving, and the evidence suggests a chilling truth. Size was no longer the ocean's only currency. Intelligence had entered the evolutionary arms race. What began as a shift in behavior soon transformed their entire physiology. While most apex predators of the time were built like war machines, all muscle, mass, and momentum, citoniensis took a different path. The fossil evidence suggests a predator designed not to crush, but to calculate. Its intelligence wasn't just housed in the skull, it shaped everything from its sonar to its speed. Skulls recovered from late Pliocene formations in Tuscany and southern Italy reveal a striking cranial structure. The asymmetry of the skull, a feature associated with advanced echolocation in modern toothed whales, indicates a high degree of acoustic specialization. This early killer whale ancestor may have used biosonar not just to locate prey, but to coordinate movement, interpret spatial patterns, and track group behavior. In short, it could hear in 3 dimensions. The brain case itself was proportionally large. Though true endocast data remains limited, its estimated encephalization quotient places citoniensis above most marine mammals of its time. This wasn't a fluke, it was a frontier. Evolution was pushing cognition as a survival tool, and citoniensis was among the earliest to weaponize it. Its diet reflected that flexibility. The conical teeth lacked the crushing adaptations of Leviathan or the slicing blades of shark lineages like Hemipristis, but they were ideal for gripping. Wear analysis and stable isotope studies from enamel samples in Piacenzian fossil beds suggest citoniensis hunted a wide variety of prey, likely fish, squid, and smaller marine mammals. This generalist approach was rare in a world of specialists, and it may have allowed citoniensis to thrive where others competed themselves into extinction. But anatomy alone doesn't explain its success. Behavior was the real breakthrough. Modern orcas are masters of cooperative hunting, known to coordinate, communicate, and adapt their tactics in real time. Some scientists believe these behaviors have deep evolutionary roots, possibly tracing back to species like O. citoniensis. If early killer whales were already experimenting with group coordination, they weren't just surviving among giants, they were outmaneuvering them. Picture a pod driving a fish school into the shallows, or flanking a young whale and isolating it from its mother. These weren't brute attacks. They were plays in a long, silent game of survival, and citoniensis may have been among the first to learn the rules. The fossil record doesn't preserve social structure, but it does hint at something more powerful: adaptability. And in a world where extinction was often one mistake away, adaptability was everything. Orcinus citoniensis may not have had the bite of a megashark or the bulk of a prehistoric leviathan, but it had something far more dangerous: the ability to plan, to pivot, and to pass knowledge forward. For all its intelligence and adaptability, Orcinus citoniensis eventually vanished. By the end of the Pliocene, around 2.6 million years ago, the oceans began to change. Global cooling intensified, triggering the onset of the Pleistocene ice ages. Sea levels fell dramatically, in some places by more than 100 meters, as massive glaciers expanded across North America, Eurasia, and the Southern Hemisphere. Ocean currents shifted, nutrient flows collapsed, and many shallow coastal habitats were either lost or radically transformed. For a predator like citoniensis, specialized for warm, semi-enclosed marine environments, these changes were catastrophic. No complete skeleton has ever been found beyond the Piacenzian layers of the Mediterranean basin. While fragmentary remains continue to surface from Pliocene-age strata in Italy, Portugal, and possibly even North Africa, there is no evidence that citoniensis survived into the Quaternary. And yet, not everything disappeared. Genetic studies of modern orcas, Orcinus orca, show that their lineage diverged from other delphinids around 5 to 6 million years ago, aligning almost perfectly with the rise of citoniensis. While no direct DNA link can be recovered from fossils this old, anatomical continuity between the two species is strong. Similar skull shapes, tooth structures, and cranial asymmetry suggest descent, not coincidence. Behavioral parallels are even more striking. Today's orcas exhibit the very tactics that citoniensis may have pioneered: coordinated hunting, vocal communication, dietary flexibility, and even culture. Learned behaviors passed down through matrilineal lines. These aren't just traits. They're survival strategies that have allowed Orcinus orca to colonize every ocean on Earth, from the Arctic to the tropics. Where citoniensis once carved out a niche in a single region, its descendants became global tacticians, splitting into ecotypes, specializing in everything from seals to sharks to herring, and adapting their hunting methods accordingly. Some modern orca populations even retain vestigial behaviors that echo the ancient tactics imagined for their ancestor: wave-washing seals, stunning fish with tail slaps, or using echo-based navigation in pitch-black waters. What disappeared in the bones survived in the brain. In this sense, citoniensis never truly went extinct. It transformed. The species vanished, but its blueprint lived on, evolving, diversifying, and ultimately becoming one of the most intelligent and adaptable predators Earth has ever known. It allowed a smaller predator to manipulate larger ones, to solve problems that force couldn't, to hunt not with reflex, but with memory. And that shift, which may have started quietly with Orcinus citoniensis, eventually reshaped the oceans themselves. Today's killer whales are apex predators not because of muscle, but because of their minds. They recognize individual voices within their pods. They invent hunting techniques specific to regions, prey types, and sea conditions. Some orca populations pass down these behaviors for generations, a form of non-genetic inheritance scientists now describe as culture. This isn't metaphor, it's measurable, and the roots of this culture may go back millions of years. When modern orcas split into distinct ecotypes, residents, transients, offshores, and Antarctic varieties, they didn't just adapt physically, they split behaviorally. Resident orcas in the North Pacific hunt fish using long-range sonar clicks and underwater vocalizations. Transients remain silent, ambushing marine mammals with surgical stealth. In Antarctica, some orcas coordinate to create synchronized waves that wash seals off ice floes, a tactic that requires both planning and trust. Neuroscientific studies of orcas reveal a brain that mirrors this complexity. Their cerebral cortex, responsible for reasoning, decision-making, and social processing, is highly folded and densely connected. Some regions of the orca brain even appear more elaborate than those in great apes. The paralimbic lobe, in particular, is thought to integrate emotion and cognition in ways we still don't fully understand. They mourn their dead, they play, they teach, and they do something few animals on Earth have mastered. They cooperate with intention. Some lineages vanished, others adapted, but from the late Pliocene onward, the marine food web began to tilt toward a new kind of power. Not jaws, not armor, but minds working together. In a sea once ruled by giants, thought had become the apex trait, and the orca is its living monument. In the modern ocean, the predators have changed, but the strategy that once set Orcinus citoniensis apart, that strange early spark of cognition, still dominates. It's there in the haunting vocalizations of an orca pod navigating fjords beneath the aurora, in the synchronized movement of a dozen bodies working as one, in the intergenerational wisdom passed down through matriarchs that remember migrations older than recorded history. It's easy to see modern orcas as an endpoint, a polished product of natural selection. But they're not the end. They're a continuation, a living thread that began over 5 million years ago in the warm waters of the ancient Mediterranean, when evolution gambled on a new weapon, the mind. And what began as survival through thinking became something more. Through each descendant, through each adaptation, intelligence didn't just persist, it expanded. Killer whales today are more than just apex predators. They're cultural agents, environmental engineers. Their presence in an ecosystem can alter the behavior of other species, even change nutrient flows. In parts of the Arctic, scientists have recorded entire seal populations shifting patterns to avoid transient orca pods. In South America, pods that beach themselves to catch sea lions have passed the technique through generations, treating local shorelines like inherited battlegrounds. All of this, the strategy, the memory, the communication, might trace back to citoniensis, a whale no larger than a dolphin, living in a time when intelligence didn't yet rule the sea.